In this chapter, we will explore the current trends in networking technology that are transforming how we connect, communicate, and manage data. As technology evolves, these trends not only enhance network performance, but also introduce new opportunities and challenges for users and organizations alike. Key trends in networking software defined networking, SDN. Description: SDN is a network architecture that separates the control plane from the data plane, allowing centralized management of network resources through software applications. Benefits: flexibility. Administrators can easily configure and manage networks without needing to physically access devices. Efficiency. Optimizes network performance by dynamically adjusting resources based on real-time demand. Real-world application. Organizations can implement SDN to quickly adapt to changing business needs, such as scaling up resources during peak usage times. Network function virtualization, NFV. Description: NFV involves virtualizing network services that traditionally run on proprietary hardware, allowing them to run on standard servers. Benefits: reduced costs. Lowers capital expenditures by using less expensive hardware and reducing reliance on specialized devices. Improved performance. Brings network functions closer to the end users, minimizing latency and enhancing user experience. Real-world application. Telecom companies use NFV to deploy services like firewalls and load balancers more efficiently, improving service delivery and reducing operational costs. Cloud networking. Description: cloud networking integrates cloud computing with networking, enabling organizations to manage their networks through cloud-based solutions. Benefits: scalability. Easily scale resources up or down based on demand without significant infrastructure changes. Cost efficiency. Reduces the need for on-premises hardware, leading to lower maintenance and operational costs. Real-world application. Businesses leverage cloud networking for seamless collaboration and data sharing across remote teams, enhancing productivity. Internet of Things, IoT. Description: IoT refers to the network of physical objects embedded with sensors and software that communicate and exchange data over the internet. Benefits: data collection. Enables real-time data collection and analysis, leading to informed decision-making. Automation. Facilitates automation of processes, improving efficiency in various industries, including healthcare, manufacturing, and smart homes. Real-world application. Smart home devices, such as thermostats and security cameras, allow users to monitor and control their homes remotely, enhancing convenience and security. Edge computing. Description: edge computing processes data closer to the source of generation rather than relying on centralized data centers, reducing latency and bandwidth usage. Benefits: faster processing. Enhances response times for applications that require real-time data processing, such as autonomous vehicles and smart city applications. Reduced latency. Minimizes delays in data transmission, improving the performance of time-sensitive applications. Real-world application. Retailers use edge computing to analyze customer behavior in real time, enabling personalized shopping experiences and inventory management. G technology. Description: 5G is the fifth generation of mobile network technology, offering significantly faster speeds, lower latency, and greater capacity than previous generations. Benefits: enhanced connectivity. Supports a massive number of devices, making it ideal for IoT applications and smart cities. Improved user experience. Provides seamless connectivity for high-bandwidth applications such as virtual reality and high-definition video streaming. Real-world application. 5G networks enable smart city initiatives, allowing for real-time monitoring of traffic, energy usage, and public safety systems. Conclusion: current trends in networking are reshaping how we connect, communicate, and manage data. From the rise of SDN and NFV to the integration of IoT and edge computing, these advancements offer significant benefits but also present challenges that organizations must navigate. Understanding these trends is essential for IT professionals and businesses looking to stay competitive in an ever-evolving landscape. In the next chapter, we will explore the implications of these trends on network design and management reliability. If you enjoyed this episode, don't forget to like, subscribe, and hit that notification bell so you never miss an update.